Hi, this is Tim. If you work with 4 to 20 milliamp signals long enough, eventually you're going to need to measure them. And it can be one of the most confusing signals to measure. So in this video, we're going to talk about how to measure a 4 to 20 milliamp signal, and also how you can quickly blow the fuse in your multimeter while you're trying to do it and not realize it. Note that this is an excerpt from a live stream, so it is not perfect. The next thing we need to talk about probably is what happens if we had trouble. In other words, what if, like even now, let's say we're looking at these values right here. We see that one of these is 18.5, and we see that one of these is 19. And we're like, I don't know which one's right. And we want to measure it. Measuring a 4 to 20 milliamp signal may be one of the most difficult things that you have to do if you're not familiar with it. Because first of all, people want to go and they want to get a current meter. And we had a current meter sitting right there at the training facility to show you. But you know, they have the clamp meters and you stick them around a wire. Those do not work for measuring milliamps. They work for measuring big amps. So if we had a motor and we wanted to, you know, its full load amps was 12.3 and we wanted to check it, we would use a clamp meter to do that. Aside from some of the high-end Flukes, they do have one, and you can tell it's a small little clamp, smaller than my pinky finger, or probably about the size of a pen. Those are clamps for milliamp signals. They're expensive, and they're actually unnecessary, because we can do that with a typical, sure I got the right meter, with a typical $10 meter, as long as we can break the loop. So now we want to check the loop. So if we go, and man, the screen lighting just isn't, yeah, our camera is just not as good on this. And hold on, let me see if I can find a picture of this really fast so I can explain. Yeah, the lighting, everything is better down at the PLC lab. It's just set up for that. And honestly, we set up, you know, everybody used to complain about the lighting here, but you got to remember, we're usually building control panels. We just cleared this whole place out really fast so we can move this down here. But if we go and look, okay, and actually, yeah, we're going to get real cheesy here. Here's a video I did that had the meter in it. Okay, right here is a typical meter. Let me get over here. So yeah, oh, and since that popped up, yeah, don't forget to subscribe to our channel. Can't get it to stay there, but yeah, hit that subscribe button, like our channel. We put out at least one automation video a week, and this is a typical meter right here. So on this side, you see that we have a V signal, and then we have a line and a dash line underneath it. And this is going to be DC volts. And then over here, we have a V, and then we have a squiggly line, or a sine wave. And that's going to be AC volts. And DC stands for direct current. AC stands for AC current. So this would be the 24 volts. And that is typically on our trainer. And then this would be, you know, our wall power, our motor power, things like that. But okay, and then over here we have ohms. And those are the ones that most people are familiar with. They can handle, really, we'll call it, they can handle, you know, the, you know, 200 degrees of the meter. And then they ignore most of this other stuff over here. Because we got this transistor thing that honestly, I would have to pull the manual out and figure out myself. But yeah, we can check transistors, we can check PNP, NPN, and I have no idea how to do it without a manual. But then we have this amp side here. And the amps right here, first we have microamps, that's what that U thing is. And then we have 2 milliamps, we have 20 milliamps, and we have 200 milliamps. And then unfortunately in this picture, it's not going to show the bottom here. So let me switch to this, and hopefully it'll come in clear enough. As then, if I pop my leads off here, we have 3 leads on this meter. But we have 3, man, that is just horrible, guys. Oh, there we go, I can get a little clear on it. That's close. Sorry about the lighting and everything. But we have 3 posts on this. And so we have our common, and then this one says volts, ohms, and milliamps. And then this one says 10 amps. So first is, where do your leads need to go? And this is different depending on your meter. So in this case, we still want to measure milliamps. So we need to go to volts, ohms, milliamps here. And then in this case, this one needs to go to common. Now here's the trick to measuring a milliamp signal. And this actually goes for volt for our 4-wire and for our 2-wire is if we go and look at how we measure one, is this right here is how we're, so this minus this right here, this is what we had before. Let me pop back over so we can just see. This was our basic 2-wire. Oops, popped to the exact same one. Where'd it go? Oh, get over here. My screens are backwards, man. Everything left needs to go right. Everything right needs to go left. But okay, so this is our typical 2-wire setup that we just made. Is now we want to measure this. Is what I see a lot of people do is they're going to put the plus here and they're going to put the minus here and try to measure this. And there are a lot of pitfalls to doing that. We'll talk more about that in a second. I'm sorry, they would actually do it here. They want to measure this milliamp signal. They're going to hit it. They're going to put their plus or their black lead here, and their minus or their plus or their red lead here, and their black or their minus lead here. And that's not how you measure a current signal. And that's what you got to think about: is what are you measuring? If we're measuring voltage, that's what we do. We would check between the points that we want to see the potential voltage of. But in this case, we want to measure the current that's moving through this wire. And in that case, we're going to need to break this somewhere. And so to do that, and unfortunately I don't have the right, I had all this printed out and we left at the PLC lab, but this is almost it, is we're going to need a second analog input, and we're just going to cut right into it. So right now we have that sensor, which is our analog simulator, and we're going to put it to the red terminal of our meter, which is the plus of it, and then the minus we're going to put to the plus of our next one. So we're looking here is I have our 24 volts. You know, no matter what you do, wires always end up tangling. There we go. So we have the plus 24 volt going to the black terminal here. And then right now, this one is going to our PLC input. So what I'm going to do is I'm going to, well, first I'm going to put my meter on milliamp. And we are going to take this wire is actually, we're going to connect to the red terminal of our meter. Now I'm going to get the black post here, and I'm going to connect it back to our meter. Which one? Let me make sure you see that. Every time we take a wire loose, we get, and I'm sorry, this is not zooming well, but we get this open wire banner here. And that means the ALP2 knows that something is wrong in this circuit. And that's one of the best troubleshooting tools about it. So now I'm going to put that back into there. Let's see. Wires untangled. Oops. Okay, so we're going to have a lesson in a second because we have meter X. That's for just a second. I grabbed the wrong meter, so let me pop this back out. And let's grab the non-X meter. And we're going to do the same thing. So our red wire is going to end up on our red post, and our black wire is going to go to there. So now, put this one to 20 milliamps. And one, just so you can see, so the moment, yeah, need like 10 hands for this, but the moment that I touch this wire to complete our circuit, that open wire message goes away. So that moment it knows, okay, we're ready to go. But okay, now I can see that my signal says 18.51 amps. And I think the backlight does not work out. Oops, backlight. There we go. So you can see right there is 18.55 milliamps. Now again, you got to remember this is a $10 meter. But if we go and look, that should be pretty close. And yeah, we're at 18.59 milliamps. So when you want to measure a signal, then you're going to want to take the loop loose and put your meter in between it. Now here is the issue, and this happens, and here is what the X meter is for, is I'm going to take this back off. And we're just going to substitute meters because I get tired of changing fuses and meters to show this as an example. Is now as I'm going to do, I'm going to put this one back exactly where it was. And let's say, oh man, I think that's not the problem. And now I want to check voltage. And so without thinking, I go over here and I'm going to check 24 volts. So I'm going to put my black lead on the plus. I'm sorry, my red lead on the plus, my black lead on the minus. And I'm like, oh, well, why don't I have any power? And I'm like, my PLC's powered up. And then I look and I'm like, oh man, I forgot that I need to change the voltage. So I switch it to voltage and now I test it and it reads fine. But the moment that I touch the plus and minus to this on milliamp, I blow the fuse in this meter. And what I've done, and I keep this set up just for this, is inside this meter for that milliamp signal, there's a little 5mm by 20mm fuse. And if we look at it, it says that it has a 500, you're not gonna be able to see it. Will it show up on that screen capture? Let me go up here because I'd love for you to see this. This is important. Yeah, so right here, oops, there we go. You can see that it says, it's a little fuzzy, but this says 500 milliamp max fused. Also notice this one over here is unfused. So you're going to blow the meter if you're on this one and you go over 10 amps. But so 500 milliamps, well, my power supply is capable of putting out 2.5 amps. So the moment that I check that, it's going to blow the fuse in our meter. And this is one of the most difficult things to get people to understand is, I just showed you, yeah, now I can check voltage. We got 23 volts. And I can also check amps. Works perfectly. But it is not going to work on this milliamp scale. And everything else will work perfect. So the next thing people do is they're like, they go in, let me plug this back in. So they got the wire right, and they are sure they have this thing wired right. And put that back on milliamp. And they touch it. We got enough hands here. And yeah, we're showing almost perfect 0 on our milliamp. And yeah, this is saying 18.6, and it's showing up in open wire. And you know, they call me and they're like, hey, something's wrong with my simulator. It's showing open wire. And we go through the schematic, and their schematic's perfect. And I'm like, check the fuse in your meter. And well, actually, here's a funny side note. Is, you know, if somebody has this $10 meter here, and I tell them, hey, your fuse is blown in your meter, they're like, okay, let me run down the hardware store and grab another one. You're probably right. Somebody has a Fluke meter. Those are the ones that always get me. Is they're like, I have a Fluke meter, and it has a $38 fuse in it. I've read the manual front to back. I know how this thing works. And I'm like, I'm glad you've read the manual. Go to the page that tells you how to change the fuse and change it. You've blown the fuse in your meter. And yeah, $10 meter people, they're like, yeah, I probably did. You know, you got a Fluke, and I promise you, the fuses blow just as fast in a Fluke, because, you know, Fluke is they're gonna protect their equipment. So it'll blow those fuses, those $38 fuses, as fast as it'll blow the 50-cent fuses. Now, here's how you can check your meter. And I don't know why it took me like 10 years to think of this. And I don't know why no meter manufacturer does this. But okay, so I have this one on 20 milliamps. Now we know that the fuse is blown now. And just like we would typically check a fuse, we'd use ohms. Well, if I have this one on milliamps, and I take my other meter, and I'm going to put it on ohms. And unfortunately, this one I think I grabbed. Oh, no, it beeps too. Now I'm going to touch. Said I need a ton of hands for this one. But now I am going to touch these, and we see it's open. So you can take a second meter and ohm out the one that you think is bad. Because now I'm going to do the opposite. I'm going to switch this to 20 milliamp, just like we want to measure, and I'm going to ohm it with this one. So now same thing, if I can get this juggling act down. Shove that up there, because this is the one we're concerned with. Because remember, our bad meter will measure ohms. I touched 2 leads. Good grief, now. I touched 2 leads there. I touched the other 2 leads here. And this one's good. So there's how you measure whether your fuse is blown in your meter without having to take the cover off of it. But there, okay, so there's a little bit about how to measure a milliamp signal if it's bad. Let me put this back just like it was, because now, yeah, let's talk about, you know, we got this thing scaled. What can we do with it? I'll put a link to the 4 to 20 milliamp lesson series in the description. Till next time. Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!